Everyone, how are you doing? Welcome to Office Hours. Busy morning. Oh my gosh. A lot going on, but it is time to do some Chapter 2. Maybe we'll do the homework here to start. Let's go to replace questions on the homework. So the homework is the first thing you need to do. I'm pulling it up over here on the main screen. It's going to let me drive the window. And once you do the homework, I would do the test or the quiz. That's what I would do. But if you're in the chat, feel free to say hi. Anyone here? Bueller. Mubot's not even here. So if you're here, you beat Mubot to the... Oh, Mubot is here. We're going to restart Mubot. Mubot, we have to reset you. So, Mubot is being... Hey, David, good to see you here.
Do I really sound like Mubot? Must have ended the stream, forgot to turn off. Mubot taking over. David, good to see you there. It's wacky Tuesdays here on Stat 201. Wacky Tuesdays. I think I was showing that to somebody and being like, hey, I can do all these cool, don't let anyone in on the inside. Noel, good to see you there. Should we do the homework or the quiz? David, you're cracking me up. Okay, what should we do? We could do the homework or the quiz. I've got the homework ready to go, so we could just burn through the homework, get it done. What do people want to do? Mubot is here. Mubot's just talking away. Mubot's saying good morning over there in the chat. See, I'm not Mubot. Whatever you think about me, I am not Mubot. That is lies. Do the homework. Your call. Let me put here the homework. Go get it done. My AirPods. Friday's a blur. Let me go here. 8:13. Stat 201. Chapter 2. Homework. Question 1. Let's go do it. Main screen. Okay, we got the Stat 201 Chapter 2 right here. And the pie chart shows, and what is a pie chart? It is a univariate visualization of categorical data. You need to know that. Remember, I say the big important things. Ask questions, anything you want. So univariate categorical can be pie chart, bar chart. It's this quadrant right here because there's nothing on the left for the X variable. It's just a Y variable of interest. So bar chart, bar chart your favorite pie chart your favorite bars, Pareto plot, which is a bar chart put in order, can be called Pareto plot 2 or Pareto chart. And frequency table shows you the counts of the frequency of each group, and a ring chart. Make sure you can kind of draw a little picture of each of them so you know what these look like. And we have right here a pie chart. So it says, is this an appropriate way? Yeah, because each one, you can put each movie into a kind of a main primary category. Yeah, sure. It's fine. Next, we have, what is the least common rating? It's that little blue sliver right there, NC17, least common rating. And that's it. That's the first question. Nice and easy. But also understand you have to know a pie chart is for categorical data, a bar chart's for categorical data, a ring chart's for categorical data, and univariate meaning we're just displaying one thing, like what is the movie's rating? That's what univariate means. You've asked one question and are currently visualizing the one question. So here we go with the next question. We have Stat 201, Chapter 2, homework. Question 2, we'll get this full thing done, I think, get a little bit into the quizzes, but you can say, hey, Brian, I'm stuck on this one, and I'll jump right to it after I finish it. University teachers saved their emails from students for each student had sent them at least one email. How many emails each student had sent is marked. What does the accompanying histogram say about the distribution? Let's go take a look at the distribution. There it is. Very clearly a something monster man. Does anyone want to say it in the chat for points? I'll throw you some Mubot points to begin with, but this is very clearly a what monster man. You should know right or left skew very quickly. If you've never heard me say monster man, then you might not be in my class. But very clearly, skewed to the right, right to the high, left to the low. Whatever way the monster man's tail goes. And once you understand that, that right is to the high and left is to the low. Right to the high, left to the low. All those things right there, we talk about the monster man, and we say whatever way the monster man's tail goes. Right to the high, left to the low. Whatever way the monster man's tail goes. Right is the higher numbers, the numbers on the larger side. So this is a very right skewed. And so the histogram is unimodal, meaning one peak, unimodal. It's skewed to the right. And there was an outlier here. I think this is correct. It was common for students to send, no, not 4 to 5. No, more like 1. So it's right skew. Most students sent 1 or 2. Most students sent 5 or fewer. I think this is right. I should read it more in depth. It's right, though. I would just talk about it myself and say this is a right skewed unimodal histogram showing that a lot of students sent about 1 or 2 emails. some students sent towards 6 emails, and there's a huge outlier over here. There's a right skew pulled to the high side. So good question, right or left skew. Same sort of thing right here. So we're just rocking and rolling. Only like a minute or two per question. So here we are with stat 201. Takes me more time to do the notes. You have to know skew, which is the way the distribution is pulled in a direction towards the high or low. High is positive, low is negative skew. Sometimes you hear those terms. Describe the shape of the histogram of births. So let's look at it. This is a little left skew, left to the low. There's our right skew monster man. And this is a little left skew. We draw our monster man here. Boop, 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 boop. And it's not really bimodal. It's kind of got just a little extra. True bimodality is going to look more like that. Little bit bimodal might look like that. You really want to think about if you were to climb this mountain range, how many mountains would there be? And there is one clear mountain, but if you were to take, because some people say, well, wait a minute, I swear this is bimodal. If you were to just shave this mountain a little bit right here and put it into this, look at how it makes one clear mountain peak. You really want to see clear mountain peaks for bimodality. And statisticians can argue, you might say slight bimodality here, but I wouldn't go into saying it's really bimodal. So it is unimodal and left skewed. It's not really a good symmetric. And they're not even talking about the modality of it, but let's see. Well, they kind of are. There's a peak here. If you look at the numbers, 78, 76. So how do we determine how many modes there are based on the graph? You just kind of look at it and you say there's one strong mode, maybe a smaller second mode. The more clear the peaks on the mountains are, like you might say this is slightly bimodal, this is definitely bimodal. And you can use adjectives before it to be like, it's very bimodal or very, very trimodal. Like you can use like, or there's slight trimodality, depending on how separated the peaks are. And it's a subjective thing. Like, when does it become very to kind of? It's a little subjective. So good morning, BS right there. B. I'll call you B. I have before. I'm a B too. I'm a Brad. So choose the correct. There's the one peak, but there's not a mode down here between 64 and 66. Good morning, Molly. Ask questions you have. Does everyone notice between 64 and 66 down here, there's not a peak? Someone could argue around the low 80s, but there's the other peak, the prime. And Heather, good to see you. Ask questions if you got them, everyone here, because I'll switch questions we're doing. If you're like, hey, I'm stuck on this quiz, we'll do it. So there's really just the one clear peak. That's what they're getting to. Because if you were to say there was another peak, it'd be in the 80s, but then the bimodality ones don't tell you both. So there's a strong peak between 74 to 76. There's a minor peak, if anything, in the low 80s, but none of the questions gave us those options. We only had like, there's a peak here and it didn't work. So once again, let me just be very clear. If I was talking through this, I would say there's a very strong peak in the around 76. There's a minor peak around 80, 78, 80. See how the number line right there? So if you notice 76 is mentioned right here with there being a mode, and the 2 mode one mentions 76 but has the wrong other spot. So it's not even an option to pick that there's a second mode in the correct spot. If this did say between 80 to 82, like if this said between 80 and 82, these would both be viable answers then. So they're only giving you one viable answer because it really only is one, maybe 2 peaks, but the choices don't let you pick a viable 2-peak answer. Okay, and really good stuff on modality right there. You just have to know modality is how many peaks it has. A little bit subjective. Also kind of known as kurtosis, if you like that fun word, kurtosis. So we are on, and drop some questions in the chat. Someone be like, I am stuck on this chapter 2 quiz, because I bet you someone else is stuck on it. I know the last ones on this are tougher, so we'll get to those. Accompanying history, take a look. Same thing. Same data as last time. So we drew the monster man right to the high, left to the low, whatever way the monster man tail goes. It's so good to see everyone here. We're throwing you some points for just chatting. Remember, chat every 15 minutes. You get those points. For question 1 on the quiz, tell me what question 1 starts with, and I'll take a look, Heather. All the questions are different on the quiz for everybody. So if you can put the first 3 words of it, I'll go find it here in a moment. We'll do question 1, and you might need to. Every quiz is different for each person. So when you do the quiz, it's a different quiz each time. And so we got a left skew monster man. And so if it's skewed, this is a really good question. What happens to the mean? Yeah, let's do that. If it's skewed, the mean does what? If it's skewed, the accompanying histogram? Cool, we'll go do those. The mean will go where? So this is left skew. The mean blanks the skew. Finish that sentence. So if you have the median right here, the mean, what's the skew? Remember this from class? The mean goes, nice job, Nathan, right there. The mean goes in the direction of the skew. So the mean is going to be lower than the median. Nathan said it perfectly. Let's throw more points for that. And we're going to pin Nathan's comment right there. You have to know the theory that the mean goes in the direction of the skew. The mean will pull towards the skew. So when you see Monster Man taking the image away from us right there, you're going to see the mean goes in the direction of the Monster Man's tail. So the mean will be pulled to the left. So the mean is going to be lower than the median. So the median will be larger. And we drew that out here visually, that the mean is going to be lower. And so the median is going to be higher. So the median will be larger because the distribution is left skew, which means the mean will be lower. So theoretically. Choose the correct answer. Which one should we use? If data is skewed, the proper measure of center is the what? These are very much test questions. And then we're going to jump to other stuff. If data is skewed, we're going to do those quiz questions Peel mentioned. The table. And then if data is skewed, we already said skewed. The proper measure of center is the what? If data is skewed, the proper measure of center is the what? You got a lot of choices right here, but if data is skewed, which we already said it's skewed, the proper measure of center is the what? If data is skewed, the median. So it's skewed, and we use the median right there, boom. Awesome. And great job in the chat. Great work. Let's go do those other questions. We're going to do quiz questions right now. You got it. A huge shout out to everyone right here, just jumping in saying, can we do these questions? Because that's all you need to do is just join the chat if you're watching this right now and just say, hey, can we do this question? And we'll usually put it in line. And yeah, we're going to go find those questions. This might be it. Tell me, we'll do this one here to start. The table to the right, I think that's the one Heather mentioned. The table to the right gives the number of passengers. Yep. We're going to do this one. Let me get the notes up and just drop those questions in the chat. There we go. Main screen. Okay. How did I? Sorry, there's weird timestamps. Did I? Oh, this is the wrong. Okay. Sorry, everyone. Let me hit cancel on this. Leave? Okay. The timestamps were totally different, and I was like, how did I enter these timestamps way off? And I was like adjusting them, and I was making mistakes. So Brian, about another video might be mistakes, because I had a wrong timestamp video up. Okay, so chapter 2 quiz. I should close my tabs. The table to the right. Now, this above my head is called a what table? That thing above my head, to review, is called a what table? This thing above my head right here is called a what table? That table above my head is called a what table? I don't know is a fine answer if you don't know. The answers are in here for univariate categorical data. The table above my head is called a what table? There's a hint over here. Because this is a relative frequency table. This is called a what table? Frequency table, Nathan, you got it right there. It's a frequency table. It shows you the counts of the observation, how frequently something occurs. Like if I say, how frequently do people go to McDonald's? And we ask people, you know, did you go to McDonald's? Did you go to McDonald's? And we find out I go to McDonald's. Like how frequently do people go to McDonald's? S, you are correct right there. And Noel's got it. That's a frequency table. This is a relative frequency table. So great job, you right there. You turn it into percentages to make it relative to a percentage. So all we're going to do here to start to make this a relative frequency table is add up the amounts. I am adding up all the numbers here. I'm adding up all the numbers. And there's the grand total. Then we're going to divide all these numbers here by the grand total. So watch this. I'll show you the first one. Well, I'm going to keep that on the screen. This is easier if I keep it on the screen. So this is the total of all that. So here we go. Watch this. What is 1298 divided by 12654?
The answer is approximately 0.1026.
What is 3,533 divided by 12,654?
The answer is 0.2792.
What is what is 4,709 divided by 12,654?
The answer is approximately 0.3721.
What is 2,838 divided by 12,654?
It's approximately 0.2243.
What is 276 divided by 12,654? I messed it up. What is 276 divided by 12,654?
It's approximately 0.02181.
Okay, should be right to 2 decimals. Yep, there we go. It's more of a, once you know, it's just understanding that a relative frequency table and a frequency table is going to show you the counts of how many times a categorical variable occurred or the percentages for how often. That was the sum of all those numbers right here. So good question, Noel. We added up all these. You add up, it's blocked behind my head now. You add up all these numbers, 1298 plus 3005. Yeah, does that make sense? You add up all the numbers right here, and you get the sum of the observation or the sum of the occurrences. So it's how many, yep. Great questions. I think, Noel, you had one too from the quiz. And you don't have to use jump for this one. I would say don't use jump. And Noel, you had one. I think, Noel, you had a question too, right? Didn't you have one? We've done this one. This one's pretty easy. Falls into one group. And NC17 is the least. Pretty much. We could do that. When is data analytics 2? We could do it now, or we could wait. I have videos going over that. The traffic. Yeah, let's do the traffic. So I've got the visualization playlist, which kind of walks through kind of what you should say. And so check out the visualization playlist right here, Madeline. And thank you, Madeline. Working ahead. That's great stuff. Let's give you some points for that. The data analytics 2 is coming up here due on Thursday. So we could do it today. We got homework and quiz due tonight. But if you're here, no one else is asking questions, we do what people say. The histogram with the annual traffic accidents. So let's go find that. Movie audience. Here we go. We found it, Noel. Let's do it. And B, you got it. Get those points. Okay, so we're rocking and rolling. Stat 201, chapter 2 quiz. The accompanying histograms. The accompanying histograms. Okay, cool. Anytime, Madeline. Traffic fatalities. This is data done yearly, but if you look, the data changes the pattern by which it's collected. At around 1990, it switches to being collected yearly, and they track it every year, but they were doing a 5-year collection at the start. And then the histogram kind of shows this because these were the original, this is the collection of years, which isn't very interesting. And then these are the years that had very high amounts, and there's 2 observations in those bins. So in other words, traffic fatalities kind of bimodal, slight bimodality with the smaller, lower second mode, high strong mode here. And you can't really see the time-ordered pattern, but you can tell they changed the way they were collecting years. This is 2 univariate displays, a display of years, which is every 5 years until we get to 1991. All they did, so the highlighted areas is just showing you that 1975 and 1980 are contained in this bin. So in other words, you notice the high traffic fatalities here, more than 25,000, 27,000, 26 and 27,000 respectively. Those are contained in this bin right here. Does that make sense? Like this bin is too high because it has 2 observations in it, an observation around 26,000 and an observation around 27,000. It doesn't show you the time ordered nature of it. It's just what were traffic fatalities. And a lot of traffic fatalities per year are around 19,000 or wherever that peak is. This was a very high occurrence at the start. This has nothing to do with traffic fatalities, just how they collected years. Does that make sense, Noel? This is just how they collected the data by years. They collected 5-year gaps to start, and then they went to every year. And then this is the traffic fatalities where you can see the first 2 years they collected have a very high amount. The bars here and the bars here do not mean anything other than 1975 and 1980 are the bars contained right here. They should have colored these green. It would have probably been better. How many years are included in the histogram bars in the passenger car fatalities histogram? How many years are included? The corresponding bars in year histogram are also highlighted. So how many years are included in the highlighted bars? Okay. So how many years are included in the highlighted bars? So who knows how many years are included in the highlighted bars? It's talking about this one specifically, but how many years are included in the highlighted bars? What would you say to that? I don't love this question. 2. Nathan got it right there. It's 2. 1975 and 1980. Which years are included? Put commas between them. Well, I kind of said it. 1975, 1980. You can also tell by looking over here, 1975, 1980, and use commas between them, I think. So 1975, comma, 1980. What do these histograms taken together say about car fatalities? Got to read now. It can be assumed that the average... We can't assume. We can't assume what they were for years in between. That's extrapolation, which we haven't even mentioned that yet. Don't do it, though. There have been fewer car fatalities more recently. Yes. Think about that. Because this is 1975 and 1980, and this is all other data. So I'm pretty sure that's it. Pretty sure, yeah. Because those were the highest years, 1975 and 1980, and then all of the years. Does that make sense? Little tricky question, but we got it. I don't love this question. Here's the thing you need to know. Histograms are univariate displays of quantitative data. We could have shown this in a box plot, a stem and leaf, or a dot plot. So you have to know histograms are univariate displays of quantitative data. If you have a note card, histograms are univariate displays of quantitative data. You got to know that. They show shape, center, spread. We can tell the modality. Can you explain again why is 2 between... Oh, so it's just asking how many years is in this bar specifically? How many years is in that highlighted bar? And the years are the 1975 and 1980 year as shown here, which have a count of 1. That says 1 right there. And there's 1 1975 observation and 1 1980 observation. And when you look at the original data right here, you can see the original data has 1975 and 1980 with the very high fatalities. And that's what we see over here is the 1975 right there and 1980 data points on year. Has nothing to do with fatalities. It's just we collected a data point in 1975. We collected a data point in 1980. Yeah. Yeah, exactly. This is just years. And then down here is the fatalities. And this is the very high fatalities. It has nothing to do with the year now. It's just fatalities. So they made 2 displays, one for year, one for fatalities. So good stuff. Tricky question. Don't love it. And good news is test questions really don't look like that. You got to know things like histograms show you shape, center, spread. If data is skewed, use the median and IQR. If data is normal, use the mean and standard deviation for center and spread respectively. Those are key notes you need to know. We got a ton of these questions. This one looks pretty tricky. Uh-oh. Let's do a tricky one. My gosh. So we're going to try to do a tough question here, but please drop a question if you're doing it right now. Yeah. Can we do the chapter? Nima, you got it. You know what? Let's do it right away. You're here. I said, if you ask it, we do it. Please drop more questions in the chat. Let's throw some points your way. And then we got another one. I just joined, but have you done the homework question about the players at soccer? Yeah, we can do it next. You got it. Thank you. I'm throwing bigger points. Thank you, Kylie and Nima. Thank you, everyone, for being here. Just keep asking those questions. I said, if you ask it, we do it. And I was going to start up a different one there, but Nima, you asked it, so we're going to do that question you want us to do. And another question on the homework, so really good time on that. And once again, anytime you see me here, just ask questions. I might say like, oh, well, we're going to do this, like, especially if it's class and we're doing something. Class is usually more structured than office hours. Can we go back to the question starts, the study of running times? Yeah. So is that homework or quiz, Heather? Let me know. We've got a few here. We've got Nima's question, then Kylie's, and then Heather's. Let me know. And thank you. This is what I like. I like having questions lined up. Quiz. Okay, we'll jump back to the quiz after this homework. So maybe throw another homework question. We might be able to get them all done. Let's go here. Let's see, is number 5? A survey of students. You can wait. Awesome. What I'm going to do is I'm going to get through the full homework because I think we have 2 homework questions. And Heather, I'm going to pin your question right here so we do not forget it. I'm going to do the full homework, which will only take like 5-10 more minutes. And we'll try to go quickly, but also explain all the concepts. So this one is asking about the proper measure of center. What are the only 2 measures of center you will choose between when picking the proper measure of center? So think, you need to pick a proper measure of center. What are the 2 measures of center that you will pick between? I need to hear the 2 measures of center. So that helps me know you know center is either blank or blank. And then one is picked when it's more normal. The other is picked when it's more not normal, skewed. Good morning, Braden. Throw some points. What are the two measures of center? This is your time to review, to be like, the two measures of center we will pick between are mean and median. Abby right there, more points in the chat. So another student wants to figure out the student's balance on their credit card. It's strongly skewed. So since data is skewed, we use median, and I'm not even going to read the rest of it. That's all you needed to see. Does everyone see, if you know the concepts, that center is either mean or median, picked when data is more skewed or normal, median for skewed, normal mean, you're done. If they had asked measure of spread, we would have said IQR because the data is skewed. Look for keywords like the data is skewed and we're using center, skewed data, center is median. Got it done. Okay, let's get the next one done here. We'll get all these done. No more homework. Thanos, sit away. Okay, that was only a 1-minute question. Chapter 2, homework, question 6. I don't know why I'm saying it. Okay, the accompanying histogram shows the life expectancy of 190 countries. Let's look at it. Should use the standard deviation of IQR. So we need to see if this data is what? Should we use the standard deviation or IQR? We need to see if this data is what? It's saying, should I use standard deviation or IQR for spread? Those are both measures of spread. How will I make my decision? So I'm helping you understand the steps you need to do. So when it says, should I use standard deviation or IQR? I have to ask myself, is this data what? How do I decide that? Like, why would I pick between those two? Is it skewed? Abby, you're right. And this is skewed. So since it's skewed, we're going to use the IQR. And what do we mean by skewed? We mean Monster Man. Monster Man affects the mean, also affects the standard deviation. So since it's skewed, Kylie, great job there too. It's skewed. So since it's skewed, we're going to use the IQR because the distribution is skewed. Once again, another easy question if you know what you're looking for. And it's really great if you can answer the questions without clicking the little blurbs. Like you don't click the blurbs, you get it. Now this one is the bane of people's existence. This might even be the one people were mentioning. Question 2 quiz. You got it, Noel. We'll do that one next. After Heather's, we're going to jump back to the quiz. Back. Oh, man, you guys are giving me energy. I don't even need a Red Bull today, but I'll still get one. I have an addiction, and the only cure is more Red Bull and cowbell. Okay, question number 7 on the homework. How would you expect these distributions to look? So this is really tough because it's very theoretical. How many speeding tickets do you have? I think I've only gotten one, and it was in Texas, Braden. I know, right? Favorite Red Bull if you want. Starbucks. Starbucks is more expensive. They give me a $3 drink coupon. Maybe I should use that. How many speeding tickets do you have? Who wants to say? We won't judge you, I promise. There's no judgment zone. So you think a lot of people probably have, and Abby's probably right, probably closer to 0. So you see a lot of people would have 0 and 1. Does that make sense? 3, no worries. Fortunately, I have none. See over here, 3, and then you got the people with like 20, and you're like, whoa. So very clearly, speeding tickets might be a what Monster Man? Dude, Braden, I'm throwing you crazy points. Everyone knows Coconut Berry Red Bull is the best, the white can. I'm not even joking. I'll go grab one out of my recycling container over there. Braden, you got some crazy points because you know. Skewed to the right. That is a right skewed Monster Man. Right to the high, left to the low, whatever way the Monster Man's tail goes. So because a lot of people have 1 or 2, 0, that's a very common amount. Unimodality, Nathan knows. And huge thank you to everyone for being here and practicing. The distribution is probably unimodal, has a peak near 0, 1, and skewed because a lot of people probably have like 0 or 1 with very few much larger than that. Very few people have a lot of speeding tickets. As long as I'm reading these properly, we're good to go. The next is players score number of strokes in the U.S. golf. Now, I'll say this one. I hate this one. I'm glad we're doing it here because I'm pretty bad at this. Probably, and this is in the U.S. Open. So a lot of golfers are going to be of similar skill. And then you're probably going to have where people could just do much worse and have a bad day. I think this is still going to be right skewed, and we may get this wrong. But if you do, it's like 70 is usually about what is good, maybe around there. You might be like, Brian, 68 is better in the U.S. golf. And they're going to have players who do really good, and maybe you have some who do poorly. It might be like that. It might be right skewed. It might be right skewed bimodal. And then let's read the answers. That usually helps me on these because this one is like the worst. Sorry. Okay. Every golfer will not have a different score. That is not what happens in golf. Most golfers will be either very high or very low. Yeah, I know, Noel. This is a tough one. More golfers will score above the mean than below the mean. Every golfer will score above the mean. That's not how the mean works. So we have two completely wrong answers. Everyone can't score above the mean because then the mean would not be the mean. Every golfer won't have a completely different score. I mean, that's theoretically possible, but usually not how it works. More golfers will score above the mean than below the mean. So more golfers will score above the mean. This would be by modality. Most golfers will score either very high or very low. So that'd be bimodal. I think it's skewed. If more golfers score above the mean, then it's going to be left skewed. I'll draw it. That's, man, I'd love to talk to a golfer on that. So what it is, let me draw it out for you. My drawing was wrong as I read the answers. It would look like this, where you have like 70 here, and that would be the median. And then a bunch of golfers are going to have really awesome scores. And this would be the mean. And these really low scores are pulling it down. So more golfers are scoring above the mean. Does that make sense? So it's left skew. Here's the thing to know. The test question is, first off, what way is this skewed? I know, right, Heather? This one's not my favorite. I thought I was going to get it wrong. What way is this skewed? This is test question now on this. So if you're worried about test, what way is that skewed? What way is that skewed? Left skewed. Left skewed Monster Man. Left to the low, right to the high, right to the high, left to the low. Whatever way the Monster Man's tail goes. If the data is left skewed, what will be lower? If the data is left skewed, what will be lower? If the data is left skewed, what will be lower? These are the things you need to know. Careful. Nope. Don't worry, we're throwing points, 500 points. Kylie got it right there. The answer is the mean will be lower. Because the mean, what's the what? Because the mean, say it with me again, if the data is left skewed, the mean will be lower. Because the mean, what's the what? The mean will be lower than the median, because the mean, what's the what? And Noel, you're on the track with that. Think of it like something's the skew. These are the things we need to know. Like I focus on like what you'll need to know for the test. Pretty much Kylie's on the right track right there. I'm making Kylie a mod. Going out of the way here. The mean is highly influenced by outliers. The median is not. Also test question related. And then the mean follows the skew. So when there's skew, the mean follows it. So if you notice the mean is being pulled in the direction of the skew, the median is not impacted by skew and outliers. So good stuff right there. Really good stuff. Weights of female babies born in particular hospital over a year. Probably got some heavy babies and light babies, maybe. So if I'm saying heavy babies and light babies, Brian's thinking the distribution is what? You got some big babies and you got some small babies. Or maybe it's more normal. Most babies are like 8 pounds. I don't know. I was thinking bimodality to start. Let's look at the answers. Every baby will have a different weight. Nope. That's not the way baby weights work. Some babies will be much lighter than the rest. Maybe that's premature. Most babies will be either very high or very low, with a few babies in the middle. No, a lot of babies are towards the average. So that's what I think. Most babies will have an average weight. So the distribution would probably look like this. Most babies will have an average weight. So it's going to be unimodal and probably symmetric. Baby weights are more normally distributed. Like, just to draw it out, like, is it in ounces? No. What do they measure babies in? Yeah, pounds and ounces. That's what it is. We need to do grams and kilograms. Because, like, ounces are just weird. And so, like, 8 pounds might be around there. It was like 9 or 10 pounds. That was a big baby. So, there we go. The average length of hair. Anyone ever hear about the awkward length of hair? Anyone ever grow their hair out and you reach a phase? No, hey, shouts to you, whatever haircut you got. I do my hair. I've had my hair short. I've had my hair past my shoulders. And to me, there's a certain phase that I call the awkward phase. And I think it's when you reach to about here. That's to me. If you have your hair that length, it just doesn't work for me. That's not my hairstyle. It's yours? Yeah. I bet you look awesome. This is not mine. Someone no. To me, no one in the chat's like, I don't know. But yeah, exactly. And I think we each have a different point. Like, I bet you someone would look at my hair when it was like at a certain length and be like, oh, that's your awkward face. I'll be like, no, that's like where I was trying to go with it. I'll be like, oh. But I think a lot of us has had that. So when you look at lengths of hair on people, we'll draw a little mannequin right here. It's Squidward right here. Here's Squidward growing his hair out. And people either usually have like that cut, which I kind of got right now, or you got another Squidward over here. That's all I can draw. I can't draw people. That's a bigger Squidward. And then people have this cut of hair. So I'm kind of trying to tell you, and there's total in-betweens, but with hair lengths, we might see more of a what? With hair lengths, we might see more of a what distribution. By me saying there's like a this length and there's a that length, I'm trying to point to you a what in the shape of the distribution down here, a what in the shape of the distribution. Bimodality. We've got kind of a shorter length of hair and a much longer length of hair, and then there are people with a medium length of hair, but you don't see that as much. You see the short and long. And then there is no limit at which you can grow your hair out. There's no upper limit to how long your hair can get. There is the limit of you can be completely just no hair. So what you notice right here is this would be right skewed bimodal. Does that make sense? There is the limiting factor of your hair can only be so short, and then your hair can keep growing longer, which means right skew, right to the high, left to the low. And this monster man has a second monster man over there. So it's a bimodal monster man with a right skew. So that is bimodality, right skew. I've done this question a lot of times. So this is bimodality skewed, and most, it's possible to have very long hair, but your hair can't be negative. So once again, you can see the answer blurred right there. Men and women have different distributions and may have different modes. It is possible to have very long lengths of hair, but hair lengths can't be negative. So good stuff. We're almost done right here, and then we're going to try to jump over to those quiz questions. We do have class coming up, so let me get done with this. That was a long one. This will be a shorter one. Okay, last one right here. I bet you someone jumped to the end of that question. You're watching this right now, rewinding time. Be like, let me see those answers. It's all right. Hey, you're getting hundreds on the homeworks and doing all the tests. I like it. Okay, so here we are. The Center for Disease Control lists the deaths from people in the U.S. Heart disease, number 1. Take care of yourself. Do some exercise. Eat well. Drink water. Get good sleep. It is reasonable to conclude that heart or respiratory disease were the cause of 29%. And it says heart or respiratory, so we need to add those. So heart is 23.5. Respiratory is 5.7. And there it is, about 29%. Yes. So yes, there's no overlap because they're going to mark one thing. It's a little bit of a weird question. Yes. What percent of deaths were not listed? We're going to add up all these totals right here to find out the missing category. 23.5, 22.5, 5, 5.7, 5, and we get that and we subtract from 100. So the methodology, once again, I want to say it again, is to add up all those, subtract from 100. So if you were to add up this now, you should get a total of 100 when you add up all those numbers. 38.3. Check answers. Which of these shows the proper way to display it? If you look right here, we have an other group, which we need that, and that should be 38, a little over a third, a little under a half. There we go. We've done it. Let's get some points. Let's do some homework. Heather's got the first, our quiz. Let's jump over here. Okay. Quiz question time. Can we go back? So I looked at the running times. Oh, the movie running times. How's everyone doing in the chat today? We've done a lot of quiz. And I want to say a huge thank you if you're starting this early. This is a tougher one, and I want people to keep their hundreds. I want people to keep their hundreds. I want you to have your hundreds, doing good. Oh man. My wife and I were playing Diablo 4. It was nice. We got some mythical weapons. Good stuff. Got to play some video games. Okay. Chapter 2 quiz. And a study looked at. Okay, someone's like, wait, you're not showing the question. Gotta find it. A study looked at body fat. We might need to do one of those because those require a jump. Of course, I'm not going to find it. That's a tougher one. And I have videos over all these. If you're looking for one, you can type in the question and you can usually find it. Oh, wait, we were going to do this one last. This is what I was going to do it a second ago. Okay, here we go. A study looked at the running time of certain movies, and we have from 2005, and it's shown to the right. It's mostly symmetric, and it gives you Q1 and gives you Q3, which are the 25th and 75th percentile respectively. And so what we'd have right here is Q1. Let me go grab there a second. And the standard deviation, which is a measure of spread, is a standard deviation of about 20. So standard deviation equals 19.9. And the median would be somewhere between those. Describe the spread in running times on the quartiles. Okay. The middle 50%, that's what the IQR is, goes between 98 and 117, measure of 19. That's the middle 50%. Q1 to Q3 is the middle 50%, and that is known as the IQR. This is the middle 50% of the data is contained between this from Q1, which they gave us, to Q3. Think of 3/4, 1/4. The middle 50% is between your Q1 and Q3. If you had 4 quarters, Q1 would be here, Q3 would be here, and this is the middle 50%, the IQR. On average, movie lengths varied from the mean, because the standard deviation is how much do things typically deviate from the mean by a running time of 19.9. So remember, we looked at the formula in class, if you're in my class, and we saw that it's a deviation on average from the mean. Since the distribution appears to be mostly symmetric, mostly symmetric, there shouldn't be concerns about these descriptions. There would not be for these data. Neither description is misleading. It doesn't look heavily skewed. It might be skewed to I don't think they're going to call it skew. I don't think they're going to call it skew. Woo! Got scared. Once again, the mean and standard deviation are heavily impacted by outliers. So if this was skewed, we wouldn't use the mean and standard deviation because they're impacted by outliers and skew. So really, there's no concerns. You could technically use either, but I would use mean and standard deviation because the data is more normal. And the more skewed it gets, we don't use the mean. We don't use the standard deviation. So if it was skewed, we would say there are concerns about using the mean and standard deviation. Yeah, good question, Heather. That is a tough one. Gave me a scare. I was like, uh-oh. I'm gonna get it wrong. We're gonna get a wrong question. I've done it. I don't think we've gotten many, if any, wrong so far this semester, but we do it sometimes. We get a question wrong. Noel had a question here. The data accompanying are the deaths from the floods. Let's go find those floods. Ooh, I think this is one of the ones we have to use jump on. It's around here. I think it's a jump question. Here it is, jump question. Some of these say, and let me mark this, and this is a really good spot, as in I'm glad we're doing this one, and oh. Okay, the data in the accompanying. Okay. 2017. I swear they update these to like, you're like, oh, look, it's a recent question. I've seen this one for a decade. Okay, so this one is a lot easier if you use jump. You can also use the descriptive statistics in the TI calculator. I need to drop probably that video link for people here, but if you're watching this right now, I show how to, do I show how to enter data? Let's go to that. Different version? Yes, and we'll do version number 2. I'm gonna find this really quick and then we'll do version 2, and that might be towards the end. 11 people watching, I love it. Usually we don't get that many live, but that's awesome. So we'll do the other one, Noel, for you here. TI, I'm looking for my TI tutorials because I want to show it in class too. 2 seconds. I might have a quick command from Ubot. So here, oh, no worries. Thank you. I'm just glad we got some appeal here. The 5-number summary. So here's how to do the 5-number summary. I think I show how to enter. There's how to enter in the data into your calculator. And once you enter in the data, you can do it on the TI calculator. So I don't have my emulator anymore for the TI calculator. And do I have an exclamation mark TI in here? If not, I'm going to give MuBot this link. So 2 seconds here while I program MuBot in the background. So that way I never have to do this again. I can just tell MuBot to do the... Oh, he already knows it. Well, cool. Well, I did it years ago, and I forgot I did it. There you go. So links are in the chat right now for the TI playlist, and it'll show you how to do this. You can do it with the TI, or you can do it my way right here. We're going to go here to copy the data. To copy the data, click the drop-down box here. Nice job there, B. Click Copy to Clipboard. Under Copy to Clipboard, hit Control-C or Command-C. Control-C on a PC, Control-C, Command-C on a Mac. Now hit Done. Now go here to your jump. Under jump, go to File, New, Data Table. File, New, Data Table. And with File, New Data Table, go here and hit Control V. And now make sure the first number is not at the top. You can also do Edit Paste, but don't do paste with column names this time. There's no column names, so don't paste with column names. Now that you have it pasted in, you're going to go here to Analyze Distribution. Analyze Distribution. Under Analyze Distribution, you're going to double-click the variable, and now click OK. Now you're going to click the top red arrow over here, this very top red arrow, and click Stack. There's all the information. You can also add in other information. You can tell there's a right-skewed monster man, but click here on the red arrow. And under this red arrow, go to Customize Summary Statistics. This allows us to add in more things, which we might need. We're going to click this, and we're going to add in the skewness. We'll see right skewed to the positive side. We're going to add in the IQR, the interquartile range, and the range. We've clicked those. We've clicked skewness to see positive right skew, range, and IQR, interquartile range, and we click OK. And this pretty much has all the answers for us, like the mean, the standard deviation, the median, the IQR. The IQR is actually calculated right there, which is going to be 211 minus 37.5, and the range. Now, sometimes Jump can get this wrong. If you're in my class and you did this and Jump told you wrongly because of the way we calculate stuff sometimes, I could go more detail, but there's 9 ways to calculate the IQR, and yeah. So what I'm doing right now is, here I'll put it side by side, and then we'll do Noel's question. Thank you, Noel. Is I am literally going right here and just entering in the data. So the mean is 133.62. The median is 54. The Q1 is 37.5. You gotta hope Jump didn't get that one wrong. The range is the max minus the min, which we could do ourselves, or we could just find out from Jump. It's 532. That's the range. The Q3 is the 75th percentile, which is 211. The IQR is Q3 minus Q1, which is going to be 173.5. And have they corrected these? We got it right. Lately, Jump's been getting them right. Please let us know if you get it wrong. And let's see the other accompanying histogram one. But that's a good question. Is it this one, Noel? Is it this one? Let me know, Al, if it's this one. No? Okay. Because this one's the same one. I want to make sure we do yours. You said it's the data in the accompanying shows the annual number of flood deaths. Okay. We will find it. Is asked how it's skewed first? Okay, cool. We will get that one. Where is it? Noel, am I missing it? Did you see it in any of these? Am I going crazy, Noel? Literally the last one. Literally the last one. Oh, here we go. Literally the last one. Okay, so how does this distribution look? Ooh, okay. So notice they only show you the data. So we're going to copy the data, copy to clipboard, and then we're going to hit Control C, Command C. Now we hit this right here. We go back into jump, and you'll be able to see the answer. So if you watch, you'll be able to get to File, New, Data Table. Your data will look the same. File, New, Data Table. We'll see if it wants the data, but make sure to just paste the data like we did before. And now we're going to analyze the data by going to Analyze Distribution. Analyze Distribution. Under Analyze Distribution, make sure to double-click the data, then click OK. If you notice, it's also a right-skewed distribution. I'm going up here to the red arrow and clicking Tables Stack, or the top thing, go to Stack. The most extreme is 555. Let's put our data side by side here so we can see it with the question. And let's see what they ask. Okay. The distribution of deaths is right skewed, right to the high, left to the low, whatever way that monster man's tail goes. And it is only unimodal. You see this one peak right here? There's one peak. The most extreme value is 555 right there, which is the highest value, which is a huge outlier. And that might do it. Yes. Thank you, Noel. And Jump can help out with that one. You can also kind of see the structure of the data. It's got a lot of just some pull towards the high values. If you look at the values right here, you can see there's some single digits. Nice job. We got it done just in time here. We're going to start up class here in a little bit. So huge thank you to everybody. Braden, Noel, 500 points for being here. Let's get ready for class. Until then, bye for now, everyone. Bye.